Hello everybody, welcome again to the ETABS and Safe course. Now in this lecture we want to export the flat slab and story 4 to the Safe to design it and check the punching shear of flat slab. We go to File, Export, Story as Safe. We select here story 4 and export floor loads only, dead load and live load. We press OK and we go to Save. We press File, Import, Save, Flat Slab. Okay, here we have flat slab. So now because flat slab we don't have beams, interior beams, we need here we need to check the punching shear of this flat slab. Also, to do the design of flat slab or solid slab, we don't need to draw design strip. So if we check the deflection of the flat slab, we can go directly to run here to the run. We can go directly to the run, and first of all we press here and show and deformed shape, and we go directly to show punching shear design. We press here and we show. If this number here we don't have number because we have an edge beams on the edge of this slab. Here we have number. If this number is below 1, so the punching shear is safe. We are safe and punching shear. For example, we have numbers with greater than 1. This thing because we have a small section of column. We want to edit it and ETABS, and also we can unlock the calculation and increase the thickness of the slab, then redo the calculation and we press show and deformed shape. So we have 1. So we don't the problem here is the columns is too small here, so we have a big punching shear. We want to edit the column and the ETABS, then re-export this slab into Safe software. This is a mistake from the ETABS. So we show here that this number is below 1, so we are safe and punching shear. Now we want to do the design of this flat slab, and we will remind that we don't need to have to draw a design strip. To do the design of this slab, we go to Display, Show Slab Design. So Display, Show Slab Design, and instead of strip based, we put here finite element based, and we press here Impose minimum reinforcing. Then we put here typical uniform reinforcing. So, and also we can here use T12 every 115 centimeter, 150 millimeter. We begin with direction 1 top bar. That means we need to put in this direction 1 and the X direction 1 bar T12, and after 15 centimeter we want to put another bar T12. After 15 centimeter we need to put 1 bar 12. We can show it in AutoCAD. So here this windows here, top 1, direction 1, and this windows means that we have a flat slab like this. We want to put a bar with diameter equal 12, and we want to continue putting this bar each 15 centimeter. Each 15 centimeter we want to put 1 bar 12 with diameter 12. Okay, and we will check here. We press apply, and the color, when we have red color, we need to increase and we put additional reinforcement with this number, and we can increase the bar diameter and press here we have also to put here columns to increase, to put additional reinforcement, so we can put a grid of T12. Then we go to this areas, red areas, to put additional reinforcement as we need. So here, for example, we need to put approximate 700 millimeter per meter. Okay, we put additional reinforcement in this area and this area and this area, etc. For direction 1, for bottom, same thing. We don't need to have to put additional reinforcement. Direction 2, we need to put additional reinforcement. Okay, and here we need to put small additional reinforcement. We can here to increase the number of bars, for example, and here we decrease the numbers of additional reinforcement. Okay, also in solid slab, the same method of design, but in solid slab we have anterior beams, so we need to design these beams like we have designed the beams and muffled slab type 1, and same method, finite element method, to design the solid slab. So we don't have to design solid slab because the same method and flat slab. And we want to remind that in flat slab we must check the punching shear parameter. So in flat slab we want to check deflection, punching shear, do the design and finite element method. In solid slab we have to do the design of beams and the design of the slab and check the deflection, and we do the design of slab below the finite element method like that we do in this flat slab. Thank you for listening. We will continue and we will begin with the design of foundation and the next lectures.